A convenience store sells 23 sodas in 12, 16, and 20-ounce cups. The total volume sold was 376 ounces. Suppose the prices for small, medium, and large are $1, $1.25, and $1.40 respectively, and that total sales were $28.45. How many of each size did the store sell? Okay, so what I like to do is start at the end of a story problem. When you look at the actual question part of the problem, it makes it obvious what the variables are. How many of each size? I'm probably finding small, medium, and large. Specifically, the number of smalls, the number of mediums, and the number of larges. So once I know that, I'll go back through and read the problem again and look for more specifics. When I see a number like 23 sodas, that looks like a total. And so I can tell that the three variables are going to add up to 23. That's how many there are. Smalls plus mediums plus larges equals 23. Continuing, I see these numbers are all talking about ounces, and I see another number that looks like a total. So I can put that back in and say something like 12 small plus 16 medium plus 20 large equals 376. Now, continuing, I see the dollar signs, and it looks like it's another problem with a total in it. There's going to be something that's a total of 28.45. So I can say 1S plus 1.25M plus 1.4L equals 28.45. All right, so there's my system of equations, and I want to solve that system of equations to answer this problem. So what we're going to do is we're going to do Gauss Jordan. So Gauss Jordan wants an augmented matrix. So take all the variables out. Top row says 1, 1, 1, 23. And in the middle row, 12 ounces, 16 ounces, 20 ounces, and a total of 376. Bottom row, 1, 1.25, 1.4, and 28.45. There's my augmented matrix. And what I want to do is I want to do a reduced row echelon form of that 3x4 matrix. Now, one thing to point out, the website I'm about to use doesn't like the decimals in that last equation. So what I can do is multiply by 100 to move the decimal 2 places. So if I do that, that becomes 100, 125, 140, and 2,845. So let's use that one. I know my website will handle those numbers now that they don't have decimals. So go to Math Sites and find the one that says Gauss Jordan Elimination. We want a 3x4. And we're going to enter in all those coefficients. So I clear out the numbers. And we've got 1s and a 23, 12, 16, 20, 376, 100, 125, 140, 2,845. Solve. This thing does the Gauss Jordan process for you, and if you look down at the bottom, it gives you your reduced row echelon form. I can see from that x is 6, y is 9, and z is 8. Or let's go back and put it in our context. So I'd like for you to write RREF, just tell me what you're doing. And then that reduced matrix looks like this. No, it's supposed to be a 9. Okay, so go ahead and put the answer back in context. That first row, x equals 6, or s equals 6, tells me there are 6 smalls. Second row says 9 medium. And the bottom row says 8 large. Should notice those numbers add up to 23. They'll do the other things as well, but that's my solution. Part B says, suppose the prices for small, medium, and large are changed to $1, $2, and $3, but everything else is kept the same. So if everything else is the same, let's look at what that matrix would be. The augmented matrix, remember, was 1, 1, 1, 23, and 12, 16, 20, 376. And it had a total of, what was it, 2845? But we're changing the dollar amounts of each individual to 1, 2, and 3. So I kept the original numbers in black, but I changed the new numbers in red. That's what it looks like. Now, you should notice something's weird about that pretty much immediately. If the drinks cost even dollar amounts, 1, 2, and 3, how in the world are we going to add up to $28.45? So keep that in mind as we do our RREF. So I'm going to go back to that site and let's change this to 1, 2, 3, and oh yeah, I can't do 28.45 because it doesn't want decimals. I forgot about that. Okay. So let's multiply by 100 again, and let's just call this 100, 200, 300, and 2,845. So that'll do it. So again, we do the process, the Gauss Jordan process, and we look down at the bottom. And if you look at the bottom row, you've got 0 equals 1. 0 equals 1 is mathematical nonsense. That tells me there's going to be no solution. But of course not. It's not going to. You're not going to have $1, $2, and $3 add up to $28.45. So of course that's not going to work. The reduced row echelon form was 1, 0, negative 1, 0, 0, 1, 2, 0, 0, 0, 0, 1. Again, that bottom row tells me this is going to be no solution. C, suppose the prices are the same in part B, but the total revenue is 48. All right, so remember our matrix was 1, 1, 1, 23, and 12, 16, 20, 376. And we had changed those prices in part B to 1, 2, and 3, but now we're going to change the dollar amount to 48. So again, the original numbers are in black. I changed the red in part B, and now I'm changing that 48. And we're going to do another RREF. So let's go back here. And I'm going to change this back to 1, 2, 3, and then that total is 48. Everything else stayed the same. So in Gauss Jordan process, we look at our numbers, and this time you're noticing the bottom row says 0 equals 0. 0 equals 0 usually tells me many solutions, but actually a better indicator is when you can see there's more variables. I see 1, 2, 3 columns, so 3 variables, and only 2 non-empty rows. There's more variables than there are equations, and so that's telling me that there's many solutions. So we did our REF, and we got 1, 0, negative 1, negative 2, 0, 1, 2, 25. And actually the 0 rows, it's not even really important. You can put them in there if you want to, but you can leave it out as well. So what happens when we know it's many solutions, we already know it's many solutions, but we can go even further than that. Remember where we're trying to get to. We want numbers along that diagonal and zeros everywhere else, but this one right here is causing us a problem. If you think about the variables, if we call them X, Y, and Z, I know it's S, M, and L, but if we think about it as X, Y, and Z, X, Y, and Z, the Z variable is the parameter. I guess we should do S. Let's do small, medium, and large because that was our variables. The L one is the problem, so L is going to be our parameter here. What that means is I want to represent M and S in terms of my variable L. So look at the middle row. The middle row represents the equation m plus 2L equals 25. What I'm going to do is I'm going to subtract this over and see that m would equal 25 minus 2L. Likewise, with the top equation, I could see the top equation says S minus L equals negative 2. I'm going to add that L over and see that S equals L minus 2. So at this point, I know that it's many solutions, but S is of the form L minus 2, and M is of the form 25 minus 2L. And then L was my parameter, so I just leave it alone. So not only do I know many solutions, but I know all of those solutions have this form. So what in the world does that mean? That means pick a number, okay? So let's say that there are 5 large drinks. That's your parameter. So just plug in 5 and see how many. You can figure out how many smalls and mediums there are based off of that. Well, if L was 5, then 5 minus 2 is 3 smalls. And 25 minus 2 times 5 is 25 minus 10. There would be 15 mediums. So I've got one possible solution of 3, 15, 5. You can do it as many times as you want, really. Let's say I pick one large. If there was one large, then 1 minus 2 is negative 1. Oops, that's not going to be possible. Okay, can't have negative 1 small drinks, so maybe we better pick 2 larges. If there are 2 larges, then I'd have 2 minus 2 is 0 smalls, and 25 minus 2 times 2 is 4, 21 mediums. Now notice those 3 numbers add up to 23. They have to, because that's part of the problem. The number of drinks is 23. But remember, we've got many solutions here. Specifically, here are a couple of examples. But all of those many solutions have this form.